Before we take a look at the conclusion statement for a two-sample t-test, let's do a quick review of how we know whether we're rejecting or not rejecting the null hypothesis. So this is going to work the same in all of our hypothesis tests. So hopefully this should sound pretty familiar by now. If our p-value is smaller than alpha, we do reject our null hypothesis, meaning that we think that the alternative hypothesis is more likely. If p is bigger than alpha, we do not reject the null hypothesis, meaning that we don't have any evidence that the null hypothesis is wrong. All right, so we're going to need to know that in order to fill in our conclusion statement. I've broken the conclusion statement for the two-sample t into 6 pieces. The first 3 pieces are going to seem really familiar, and I'm going to use that choice of do or do not. So we start out, as always, with a p-value of blank. At the blank percent significance level, we either do or do not have evidence. And then the second half of this statement, we're going to add in the context from the story. So either do or do not have evidence that the mean of group 1 is less than, greater than, or different than the mean of group 2. Okay, so there's kind of our fill in the blank for how to write our conclusion statement. So let's give this a try. A published study states giving students chocolate prior to teacher evaluations increases teacher scores. Since the teacher had 3 sections in the same class, students were randomly split into 2 groups, where one group received chocolate from the professor and teaching staff, and the other group received nothing. This chocolate appeared to improve mean teacher scores. So we're given the order of subtraction of chocolate minus no chocolate. So our null hypothesis here is that the mean with the chocolate minus the mean of no chocolate is equal to 0. And then what do you think the alternative hypothesis is going to be? We'll have mean of chocolate minus mean of no chocolate. And we're going to have that that's greater than 0. That's going to be a right-tailed test. And that's because we think the chocolate group is going to be a bigger number. So when we subtract those, we'll end up with something positive. All right, so there are 2 hypotheses. You can fill those in on the notes. And then let's write our conclusion statement. So we're given the first 2 lines with a p-value of 0.03 at the 5% significance level. And then we need to add in those last 4 lines. So I see that my p-value here is smaller than my alpha. So we do have evidence that the mean score from those given chocolate is greater than the mean score from those not given chocolate. All right, so our next one, we are looking at automobile insurance and comparing people that are over the age of 30 to people in their 20s. So what I'd like for you to do is to go ahead and pause this video, fill in those hypotheses, and give that conclusion statement a try. So we are looking at automobile insurance used to pay for any claims made against the driver in the event of an accident. This type of insurance will typically pay to repair any assets that your vehicle damages. A random sample of 30 to 59-year-olds results in a mean claim of $3,699, while an independent random sample of 20 to 24-year-old drivers results in a mean claim of $4,586. Does the data provide justification that the 20 to 24-year-old drivers should be charged more? So our order of subtraction here is the 30-plus-year-olds minus the 20-year-olds. And it does tell us that this is an independent random sample. So that automatically tells us we're doing a 2-sample t. So my null is the mu of the 30 pluses minus the mu of the 20s is equal to 0. My alternative is that the mu of the 30s minus the mu of the 20s is less than 0. Because we think those people that are in their 20s are going to cost more. So that second number is bigger, so when we subtract, we'll get something negative. Or less than 0, giving us a left-tailed test. And then our conclusion statement here. So we were given with a p-value of 0.11 at the 10% significance level. So my p-value here is bigger than my alpha. So that means I do not reject. So we do not have evidence. The mean claim of those ages 30 to 59 is less than the mean claim accident of 20-year-olds. All right, so there's our conclusion statement. Come back in the next video and we're going to work through how to do an entire 2-sample t-test from start to finish.